that if something is new, even infants will spend more time looking at it. In this case, you did too. That thing that was unexpected and new really drew your attention. And as soon as the third time, you're like, I've seen Brian Scholl's face enough. And you moved on. So there's one other point that I wanted to make off of this experiment, which is kind of a minor point. That is, one of the things you have to do is remember what you saw, right? If you saw a 3, you have to remember that until I ask you. That's actually not a trivial ability. Now, it feels fairly trivial if I just say, remember 3. It doesn't feel like that takes much effort. But if I say, remember 96602081, you remembering? Okay, good. Just keep trying to remember that. And actually don't. You won't pay as much attention to me. So don't try to remember that. But you can see that takes more effort, right? It's not just as simple as remembering a 3. That is a form of memory we call short-term memory or working memory. Now, it's not just good for phone numbers. It's good for lots of different things. So, for example, in order to understand the sentence I'm saying, you need to keep in mind the words at the beginning of the sentence to make sense of the words at the end of the sentence, right? There's a lot of processing that has to go on there. Or you can think about in music. You have to keep in mind what's going on at the beginning of a certain musical phrase in order to make the resolution or the cadence make sense at the end. A professor of mine once told one of my friends that he had long ears, and he wasn't calling him a donkey. He was merely saying that his compositional structure was such that you had to remember a lot from the early part of the piece to make the end part of the piece make sense. These are all functions of working memory. These are all things that we have to keep kind of actively in our minds. So, working memory is very limited. Who remembers the phone number? Very good. Who doesn't remember the phone number? Who's not being honest? All right. Well, I won't ask you to try it out. Don't make a fool of me. We are going to look at memory, working memory in this case in a much more boring way. Yes, we're back to shapes. Sorry. But that's a very good way to study working memory because we can study very specific features of it. So in this case, I'm showing you 3 shapes. Remember those. Remember their colors. Remember the locations. There are only 3. It's not too bad. If I asked you to remember 6, it'd be a lot harder, right? You feel that. So remembering the 3, and then I ask you, what was the shape there? You know it was a square. What color was it? It was kind of just the one that's hued here, just the one with the dark, kind of a yellowish color here. Not quite. Okay, around here. Very good. There's some group work. All right. So the good thing is there's so many of you that on average we would have gotten the right answer there. But probably there's some variation in exactly what you remembered that color to be. Some might have remembered it a little bit more orange. Others might have remembered it a little bit more yellow. There's some uncertainty to that. And some of you might have just forgotten it altogether. You were too busy trying to remember that phone number I gave out. So what can we learn from something as simple as this? Well, first of all, what do we even get? What did people respond with? One, you could have responded with the probed color. You really could have responded with that kind of yellow-orange, more or less. Second, you could have just said, I don't remember, I'll just shout out blue. Or third, you could have remembered one of the other colors that was up there. You misremembered where they were, but you remember the colors. I'm going to focus on the first 2 of those for this. Let me say that you can take this information, and we run you on a lot of trials, several hundred, in fact. We can actually apply an equation, which don't read it. I'll get to it in a second. And we can get estimates of the quantity of items that you have in your memory, and we can estimate of the quality, so how accurate you were in remembering those items in your memory. Now, the reason I have the equation up there is not to scare you, but merely to say that a lot of cognitive science deals with a lot of mathematics. And I've had a lot of students ask me with some fear, how much math and statistics do I have to know in order to do cognitive science? The answer is you need to know some. You need to be conversant with it. But if this doesn't make sense to you, and it doesn't make sense to me the first time I saw it either, then know that if this part made sense to you, then you can understand that math, and you can do these same kinds of analyses, even if this doesn't strike you as particularly illuminating. All right, so we have quantity and quality through this process. What can we do with these? It's not particularly informative just to say, aha, you remembered a certain number with a certain precision. That's not interesting. But what is interesting is trying to challenge ourselves and see how our brain responds to challenges. The first one we'll do is, the challenge one will be sleep deprivation and delay. So you have to remember things over a period of time, and we're going to sleep deprive you. Why is that interesting? Well, sleep deprivation is a problem. I'll get to that in a minute. And I had a lot of good observation when I sat in the back of the room during the talks earlier today that I think some of you might be sleep deprived. So what we did is essentially just what you saw just now, is we ran people on a task in which they had to remember 3 items. They had to hold those items in memory over a delay of either 1 or 10 seconds, at the end of which they had to make a response of what the probed item was by using this color wheel. So they just used the mouse and they moved it around and indicated what color it was that they remembered there. And they'd get feedback at the end of how good they were. Okay, so the second manipulation we have is the sleep deprivation manipulation. Now for this, we monitored people's sleep habits to make sure that they were pretty good. That's with this AccuWatch. It's just measuring movements, essentially, so we can see when people are up and about and when they're lying in bed. And you can see we have 2 different sessions for each subject, so we can compare them, their performance when they're sleep deprived with their performance when they're rested. You can see we counterbalance that so people don't get better for practice, and we're seeing an interference of those effects. You can see for the sleep deprivation session, we make people come in the night before. We keep them up all night. They do not get any caffeine. That would be cheating. And then in the morning, they have to perform this test and a number of other ones. For the RW session, it's very simple. They just come in the morning and perform the tasks. Okay, so these are the results then of what we get when we're looking, and remember what I said, we're looking at the quantity and the quality of the information. So this is the quantity. In this case, this is the probability that when we ask them what was the color in a given location, this is the probability they actually got it right. So you can see when you're rested, you're pretty good. About 90% of the time you can get that right. You can see the delay has a very little effect, so you're able to maintain those memories across time. But you can see when you're sleep deprived, now you're starting to have some trouble. Not only are you worse overall, the delay really hits you. In fact, by the point of having to remember just 3 items over 10 seconds, you're only getting it right half the time. It's pretty bad. And this is, as I say, just one acute night of sleep deprivation. This isn't even over an extended period of time. What's interesting, though, is this lower thing. This is the precision of the response that you give. And what you can see, and the biggest thing to see here, is that there's no difference between when you're rested and when you're sleep deprived in terms of how accurate you are, in how precise you are, rather. So if you remember something, you remember it very well, even if you're sleep deprived. It's just that you have a much lower chance of actually remembering it. So quantity is affected by the state, the delay, and the interaction. Quality, actually only affected by the delay. You get slightly fuzzier over time. Put another way, because we'll be comparing this in a second, the number of items is declining, but the precision of the items is not. So the second thing that we tried after sleep deprivation was just increasing the information load. So obviously that was very simple, right? Just trying to remember colors of squares. Well, now we're going to go to triangles because we're doing shapes again. In this case, let me just say a little bit before why we were interested in this. There was a claim in a paper that came out, 1997, that remembering 2 features in a given item was just as easy as remembering 1. Right? So what this claim is saying is it's just as easy for you to remember that this square had red and green as it is for you to remember that the small square in that figure was red. So that's what this is showing. There's no difference in your percent correct if you have a conjunction there. Now that is not an assessment of the quality of information, though. That is only an assessment of the quantity. So he said, okay, what about the quality of information here? maybe there's a trade-off here that they missed. So what we did is these are the triangles that I mentioned before. So now you have to remember two features about them. You have to remember their orientation, and you have to remember their color. I won't make you do it, as much fun as that would be for me. But I will show you what other people had to do. So you can see here that there's the sample just as before, and then at the end, people are asked about one of the three items. They're either asked to give the color, in which case they're responding on a color wheel, or they're asked to give the orientation, in which case they're asked on this orientation. Now, alternatively, we could tell them beforehand, this time just remember color, or this time just remember orientation. In fact, we only presented those two. Okay, so the comparison then is between when we had people remember two features in each item, versus when we had people remember one feature in each item. You can see it's a very different pattern of results. Like before, there's no change in the number of items that people are remembering. It's just they get fuzzier with what they remember. The precision drops. So if you have to remember both the orientation and the color of that triangle, your memory for both just gets a little bit less accurate, a little bit less precise. Just to compare that with what we saw for sleep deprivation, you can see these are very different effects. So, well, why? One idea, at least for the sleep deprivation, is what happens when you're sleep deprived and even if you're just, say, sitting in the audience? Do you nod off? Are you nodding off now? Maybe. And so we can call some of those lapses. And it's essentially you just kind of drop what you're doing for a moment and then have to kind of come back into the moment. And it's very difficult to do that. That lapse seems to affect whether you have an item in memory or not, but it doesn't have any effect on the precision of that item. Whereas in the case of increasing complexity, what we think people are doing is actually strategically changing how they're memorizing these things. They know they can't fit everything in, or at least their brain knows. They don't seem conscious of this. And so changes the resolution with which these things are remembered. So take-home message. Again, we face cognitive trade-offs, and the brain deals with these in different ways in different situations. Second, get more sleep. One thing you shouldn't do is play video games until the wee hours of the morning. Now, just as an informal poll, because this is always very interesting from a public health perspective, how many in the audience get no more than 10 hours of sleep a night? No more. I should see a lot more hands. No more than 10 hours of sleep. Okay, no more than 9. 8? 7? 6? Look around. That's a lot of sleep-deprived people. 5? 4? 3? All right. No one is in dire need of sleep. But if you're below about 6, you're sleep-deprived. And you're feeling some of these effects that I showed here. I'll get to in a minute why that's so important, because it's not just remembering shapes and colors that matters, obviously. A lot of other things. So, as I say, get more sleep. Now, one of the things that's kind of funny about this is that I say this to people, I'm a huge hypocrite. My hand was up until 6. I'm sleep deprived. That probably doesn't make me a better speaker. It probably doesn't make me a better thinker. But I do it anyway, because we're weird. And I would put it to you that many of you are weird as well. Anyway, most of you probably won't get more sleep. But if someone does, because of this knowledge, great. I feel like I've done a public service. So let me return to why is working memory so interesting? Well, to get to that, let's play a game. Say we have, it's not a very fun game, but it's a game you're going to play anyway. Say we have 4 cards, and each card has a number on one side and a color on the other side. Let's say that I tell you that if on one side there is an even number, the other side of the card is blue. Okay? If the one side of the card is an even number, the other side of the card is blue. Which card do you want to flip over in order to test that? Okay? Who says 15? Let's start with the 15. Okay, one person wants to test 15. Anyone want to test 22? Okay, good, healthy amount of 22s.